My name is Jake Vaughn, undergraduate research assistant with Mizzou Weed Science. The Weed Science program conducts many different experiments testing various methods of weed control, including chemical, mechanical, and cultural control practices. Today, I'm standing in front of one of our cover crop fields. Although you may not be able to see it today, earlier this spring, this field was covered with cereal rye. The cereal rye was drilled last October and was terminated this May at the time of planting with an application of glyphosate. The purpose of this experiment is to study the effects that seeding rate of cereal rye has on the growth and yield of soybean and on the suppression of weeds. Traditionally, research experiments conducted on cereal rye sow the cover crop at 110 pounds per acre. However, this may be a much higher rate than used on a typical Missouri farm. For example, NRCS recommends sowing cereal rye at 40 pounds to the acre when it is to be drilled. In order to observe the effects of seeding rate, we've compared a treatment with no cereal rye at all to treatments with 30, 50, 70, 90, and 110 pounds per acre of cereal rye. Today, we will look at the effects that seeding rate has on the cereal rye itself, as well as height, stand counts, and yield for soybeans, and the suppression and visual control of weeds. First, we'll briefly look at data collected on the cereal rye itself over the 3 years this experiment has been conducted, 2018 to 2020. Cereal rye stand counts and heights both follow a pattern of increasing as seeding rate increases. Stand counts understandably increase due to more seed being planted, and height increases due to increased competition for light in the more densely planted plots. Data for biomass was also collected, but there was no significant difference between the treatments. When we look at soybean stand counts from 2018 to 2020, we do not find meaningful difference in stand between soybeans planted into rye at the different rates and the soybeans that were planted in plots without cereal rye at all. This is promising because it demonstrates that cereal rye does not have a negative effect on soybean stand as compared to a field that does not have the cover crop, regardless of the rate the rye is planted. When considering soybean heights 2 weeks after planting, we do, however, notice a significant difference. Data from 2018 to 2020 shows that while all soybeans planted into rye had no difference in height, they were significantly taller than those plants that were not growing in cereal rye. We expect this is due to light competition, with the soybeans and rye growing more to find light in early growth stages as compared to the non-treated plots, which did not have to grow as far to find light. When we look at the yield data for 2018 and 2019, we notice, as with the heights, the yields for cereal rye treatments are statistically similar and better than the non-treated control. Finally, we come to the weed control data for this trial. This slide shows cumulative counts of Waterhemp counted over the 4-week period following planting. As you can see in this graph, the higher seeding rates of cereal rye resulted in slightly fewer weeds at between 15 to 20 Waterhemp plants per square meter. This is in comparison to the lowest rate of 30 pounds per acre that had nearly 40 Waterhemp plants per meter square. However, all the cereal rye treatments reduced Waterhemp density when compared to the non-treated plots, which is represented by the blue line at 256 Waterhemp plants per meter square. This demonstrates that the presence of cereal rye at any seeding rate has significant ability to slow Waterhemp emergence early season. It also demonstrates that while 30 pounds per acre is effective in the early season, a higher rate can help achieve longer season weed suppression. This slide compares visual control of Waterhemp 42 days after planting in 2019. This is also 2 weeks following an application of Liberty, so the ratings take into account both the control of the herbicide pass and the residual effects of the cereal rye to hold back future flushes of Waterhemp, as Liberty has no residual action. In the picture on the left, you can see a non-treated plot with both dead plants from the glufosinate application and a fresh flush of Waterhemp. As we move to the middle picture depicting 30 pounds per acre, we notice significantly fewer newly emerged weeds than the non-treated, but they are present. Finally, moving to the right picture, 90 pounds per acre appears very clean in comparison with the first two photos. These observations are consistent with the visual control recorded at the time these pictures were taken, which shows control in the non-treated was meaningfully less than the control in the 30 pounds per acre treatment, which in turn was meaningfully lower than the other rates of cereal rye. In this video, we've seen how cereal rye can help to suppress weeds in a field without negatively affecting the soybeans. We've also noted that while 30 pounds per acre of cereal rye is enough to help suppress weeds, a higher rate may be able to help maintain that suppression further into the season. Thank you for joining me today for this talk about cover crops, and keep your eyes open for future virtual field day videos to learn more about our research.